Hello children, welcome to Insight Engine Academy. So this is physics class. So we are going to talk about first chapter from 10th class, that is reflection of light at curved surfaces. So before going to discuss this topic, we need some basics to understand this lesson easily, so that I will teach some important basics in order to understand the lesson in a better way. Okay, so optics, it is a branch of physics which deals with light. So there are many phenomena of light: reflection, refraction, dispersion, scattering. There are many. Okay, in this lesson particularly we are going to talk about reflection phenomena and reflection on curved surfaces. So what are called curved surfaces? Okay, see, how is the surface of the board? It is smooth, plane. So this is plane surface. So what is a curved surface? You see, this marker has curved surface. So marker surface is an example of curved surface. This board is an example of plane surface. Reflection on plane surfaces already we have discussed in class 8. Okay, in this 10th class we are going to discuss, okay, we are going to have a discussion on reflection of light on curved surfaces. Okay, subject is physics, topic name is a reflection of light at curved surfaces. So this is our topic name, reflection of light at curved surfaces. Okay, I hope you understand what are curved surfaces. But before going to discuss this lesson, I will introduce some important basics. Okay, what is a reflection? First we are going to understand what is reflection. To understand this, you have to understand according to light. Okay, based on the allowance of light, these materials in our surroundings divided into three categories: transparent bodies, translucent bodies, opaque bodies. Okay, so what are called transparent bodies? Materials which allow the light to pass through them, they are called transparent bodies. Example: clean glass, air, water, coconut water, kerosene, diamond. Such kind of things are example of transparent material. Opaque, the second category is opaque. What are called opaque bodies? The bodies which do not allow the light to pass through them. For example, this marker, when light incident on it, light reflects, light never pass through this marker. Myself, I am the opaque body. When light incident on me, light never passes through my body. Walls, this board, okay, these are all examples of opaque. And the third category is translucent. So translucent bodies are not completely allow the light. They allow the light partially. Some amount of light they allow and some amount of light they don't allow. Such kind of materials are called translucent. What is the best example of translucent? Oil paper, trace paper, okay, dust glasses. All these are examples of translucent. We see the objects blurred. When we see the objects through the translucent material, we see them blurred. Okay, such kind of materials are called translucent. Now, especially opaque bodies, we are going to talk about opaque bodies. So I consider a plane surface, which is opaque one. It's a plane surface and opaque surface. So generally opaque surfaces are denoted with this symbol. In this way we have to denote the opaque surfaces. Now A ray of light going to incident on the surface at one of the point on the surface. This particular point where this incident ray meets is called a point of incidence. Point of incidence. Generally, what is the nature of the opaque bodies? Opaque bodies do not allow the light to pass through them. Then what happens? The ray which is incident on the opaque body, it bounces back because opaque bodies do not allow the light. That is why this ray bounces back to the same medium. Okay? This particular phenomenon is called reflection. So reflection takes place on what surfaces? Opaque surfaces. Whether curved surfaces or smooth surfaces. On both surfaces, reflection takes place. Now I am giving the important basics on reflection on plane surfaces. So this is the incident ray. The ray which is going to meet the surface is incident ray. This ray meet the surface at only one point. That particular point. Let's say that point is O. Okay. Here O is the point of incidence. Ray comes from A. Now AO is called incident ray. So this is incident ray. From O, the ray bounces back to the same medium. Okay, OB. So OB is called reflected ray. This is incident ray. This is a reflected ray. Okay. So now at the point of incidence, I am going to draw the perpendicular line to the opaque surface. This is the surface. To this surface, I am going to draw the perpendicular line. Okay, where we have to draw the perpendicular line? At the point of incidence. We can draw the perpendicular line anywhere, but here we have to draw the perpendicular line from the point of incidence, at the point of incidence to the perpendicular to the surface, opaque surface. That is called a normal. What is normal? A line which is drawn perpendicular to the surface at the point of incidence is called normal. Okay, so then we get some angles. Here we have one angle between this surface and incident ray. This angle is called a glancing angle of incidence. Here we have the angle between incident ray and normal. This angle is called angle of incidence. Here we have the angle between normal and reflected ray. This angle is called angle of reflection. Here we have the angle between the reflected ray and surface. It is called glancing angle of reflection. So here we have four angles. Glancing angle of incidence, angle of incidence, angle of reflection, glancing angle of reflection. Okay, so and one more important angle I am going to introduce. See, actually this is the path of the light. The ray has to go this way, isn't it? Okay, this is the original path of the light. The light has to travel this way. This is the actual path. But instead of travel in its actual path, the light deviated from the original path. This is the original path, but the light is deviated from the original path and travel this way through some angle, making some angle. So the angle between the original path and the deviation, that means this particular angle, this is called angle of deviation. Okay, so total how many angles we have discussed now? 5 angles. Glancing angle, angle of incidence, angle of reflection, and glancing angle of reflection, and angle of deviation. Okay, so I will give you the definitions of all these 5 angles. Okay, please you have to note down. Yeah, here we have the definitions of all these 5 angles. Glancing angle of incidence. It is an angle between incident ray and surface. glancing angle of incidence is this. This is angle of incidence. It is angle between incident ray and normal. Normal and incident ray is called angle of incidence. Normal and reflected ray is called angle of reflection. Reflected ray and surface is called glancing angle of reflection. This is glancing angle of reflection. And the angle between, okay, this is the actual path of the light. The light has to travel this way, but instead of travel in its actual path, it deviates through some angle and travel this way. So this angle is called angle of deviation. So here you have the 5 angles definition. Please note down the definitions. Yeah. Next, we are going to talk about laws of reflection. So before going to discuss the laws of reflection, first let me ask you one question. Reflection just we have discussed. Where do we see reflection in our daily life? Actually, how do you get light in your room? What are the sources of light in your room right now? If it is night time, electric bulb, tube light, candle, all these are the sources of light. Mobile phone. Okay, so mobile phone, cell phone, torch light, all these are some sources of light in night time. But what is the source of light in daytime? In daytime, sun is the main source of light. But do we have sun in our room? No. Sun is 15 crore kilometers away from here, though we are getting light. How? So from the sun releases light and heat, the light which is come and incident on the earth. So same light incident on your building, your house, as well as your beside houses, on the ground. The light which is incident on your beside house, reflection, due to reflection that enters your house through windows and doors, because that building is act like a opaque body. Okay, all the buildings and trees are opaque bodies, ground itself opaque body. So the light which is incident on them reflects and passes through window and doors. And the light which is coming through window incident on the floor. Floor is what kind of body? Opaque body. Then again reflection takes place and incident on the ceiling. Ceiling is what kind of body? Opaque body. Again multiple reflection takes place in our room. And finally throughout every corner we get the light. That is why we are able to read, we are able to do the things. We get the light in our room. Okay. So we get the light due to reflection. This is the best example. Okay. That is a daily life example of reflection in our daily life. Now, so we are going to talk about laws of reflection. Here we have two important laws. Okay. First law of reflection and the second law of reflection. So, what is the first law of reflection? I'll explain. This is opaque surface, plane surface. A ray coming to meet the surface is called incident ray. Just now we have discussed. And the ray which bounces back to the same medium is called a reflected ray. When we draw a perpendicular line, this is the point of incidence. O is the point of incidence. When we draw a perpendicular line at the point of incidence to the surface, this is called normal. The angle between the incident ray and normal is called angle of incidence. Normal and reflected ray is called angle of reflection. And the other angles also we have discussed. Glancing angle of incidence, glancing angle of reflection. But now I focus on these two angles. Okay, so first let me say what is this incident ray. This is normal, this is reflected ray. Okay, these three, incident ray, normal, reflected ray, lie in the same plane. Lie in the same plane. I will make it more clear. Okay, so I'll take this. Let's say I'll keep these markers this way. So these three markers represent the same diagram which we have on the board. So this marker black one is the incident ray, and this marker is the normal perpendicular which is drawn to the surface, and this ray is the reflector ray. This is this. See, this is incident ray, normal, reflector ray lie in the same plane. This is called plane. This is called plane. You see, when I hold these three markers this way, okay, so whenever you see this black marker, you cannot find these remaining two markers. Yes or no? Because they are lying in the same plane. Okay, but if I bend this normal this way, middle marker this way, you see only two rays are in the same plane. This ray is deviated from the plane. But in reality, normal, incident ray, reflector ray does not deviate this way. Always they lie in the same plane. This way they will lie in the same plane. Okay, if I deviate this ray, you see this one, reflector ray is deviated. Okay, only incident ray and normal are lie in the same plane, but reflector is on other plane. This deviated from the plane, but it won't happen in reality. All these three will be lie in the same plane. You see, this way. Okay, so I hope you understand. Incident ray, normal, reflector ray lie in the same plane. So this is called first law. Okay, incident ray, comma, normal and reflected ray are lie in the same plane. This is the first law of reflection. So we are going to talk about the other law, second law. What is this? This is the angle between incident ray and normal. Angle of incidence. This is the angle between the normal and reflector ray, angle of reflection. These both angles always equal. These both angles always equal. So we have the proof also in 8th class Fermat's principle. Light always choose the path that takes least time to travel. That proves angle of incidence is equal to angle of reflection. Okay. If angle of incidence is 30 degrees, then angle of reflection also will be 30. If the angle of incidence is 45, then angle of reflection also will be 45. If angle of incidence is 20, angle of reflection also will be 20. So, in 8th class also we have done the experiment, that activity to show that angle of incidence is equal to angle of reflection. This is familiar. Okay. So, angle of incidence is equal to angle of reflection. This is called second law. Angle I is equal to angle R. Always equal. So please note down the two laws of reflection in your notebook.